Okay, so we're going to start reviewing for the second test of the fourth quarter. That test is on Thursday, April 18th. Okay, that's when this review sheet is due. So for number 1, 100 patients, 100 patrons at a vet, 65 have a dog, 85 have cats, and 28 have both. What is the probability that the person chosen at random has a cat? This is what you are going to overthink because there's nothing for you really to do here. The probability that they have a cat. There are 85 people that have a cat out of the 100 people that they asked, which ends up being, you could write it as 0.85, or that also simplified down, 85 divided by 100 gives me 17 out of 20. Okay, any of those are acceptable. Don't write the percentage unless it is given to you in percentages. For number 2, we have 100 are sophomores, 87 is history, and then so the probability that they are sophomore is 100 out of 300. The probability that they love history is 87 out of 300. And then the probability of both, they're sophomore and they love history, is 51 out of 300. We want to know what's the probability that they are a sophomore or that they love history. So what I'm going to do, the probability of S or H is equal to 100 out of 300 plus 87 out of 300 minus the and, so minus 51 out of 300. So this ends up giving me an answer of 34 out of 75, if you type that right into your calculator. 34 out of 75. Okay? For number 3, algebra class of 30 students, 14 play soccer, 10 play basketball, and 22 that play either. So the probability that they play soccer is 14 out of 30. The probability that they play basketball is 10 out of 30. And 22 play either, so the probability for soccer or basketball is 22 out of 30. We want to know what is the probability that they play both soccer and basketball. Both soccer and basketball. I would do 14 out of 30 plus 10 out of 30 minus 22 out of 30, which gives me 2 out of 30 or 1 out of 15 for number 3. For number 4, high school juniors, probability that they regularly do their math cast learning. So this gives me the probability, so I don't have to do however many students do it out of however many total. It gives me the probability. So the probability that they do their math is 0.7. The probability that they do their science is 0.5. And then the probability that they do both math and science is equal to 0.35. We want to know what is the probability that they do their science given, so this is a conditional, given that they do their math assignment. The conditional is equal to both, so the both is 0.35, the probability that they do both, divided by the probability of the given one. So 0.7 is the probability that they do the math. So it's 35% out of the 70% that do their math. So you end up getting for this 0.5. Okay? And for number 5, this is one of your charts. This one's actually kind of confusing because this is talking about the percentages of each. So an automobile has 2 factories assembling 2,000 of its luxury cars. So the total number of cars is 2,000. We want to know, factory A assembled 70% of the cars. So factory A did not assemble 70 cars. It assembled 70% of the 2,000. So you need to do 70% of the 2,000. So you would do 0.7 times 2,000, and that gives me 1,400 in here. So I'm going to fill in all the information that I'm given first, and then I'll go back and fill in the table after. 85% of the cars were considered to be highly rated by consumers. So 85% of the cars, not 85% of the cars made at factory A, 85% of the total. We don't know whether they're made at factory A or factory B. So 85% of 2,000 again, that tells me that 1,700 cars were highly rated by consumers. Total is 1,700. Okay? And then the last thing that it tells me, 20% of the cars produced at factory A, 20% of the cars produced at factory A were considered to not be highly rated by consumers. So I need to do 20% of the cars produced at factory A. So 20% of 1,400, which gives me 280. That goes in for not highly rated by consumers. That's 280 here. So if I go in, right, and everything has to add up to be each other. So this is going to be 300, which means this is going to be 20. This is going to be 600, which means this is going to be 580. And then the last one is going to be 1120. All right. It says, then determine the exact probability that a car was assembled by factory B and highly rated by consumers. So we want by factory B and highly rated. Okay, so factory B and highly rated is right here, 580. And this is not a conditional, this is just an and, so it's out of the total. So 580 divided by 2,000, which ends up being 29 out of 100. This would be acceptable. This would be acceptable. Or you could also say 29%. All right? Number 6 is a little bit easier because number 6, it doesn't give you the percentages, it just gives you the numbers that you're looking for. So 500 adults, so the total, 500. Based on this survey, 240 adults smoked regularly, so this is 240. And 280 adults experienced hair loss, so experienced hair loss, the total is 280. Of the adults that did not smoke regularly, 115 did not experience hair loss, so this is going to be 115. Fill in the two-way table. So I have everything that so I can go ahead and fill stuff in. So 500 minus 280 gives me 220. Total people did not experience hair loss. If 240 people smoked regularly, that means that 260 people did not. 260 minus 115 gives me 145 people experienced hair loss but did not smoke regularly. And then here, smoked regularly, experienced hair loss, that has to be 135. And then smoked regularly, did not experience hair loss, 105. So that is my two-way table. And then it says, then determine the probability that an adult randomly chosen from the survey has experienced hair loss given that he or she smokes regularly. So given, that's a conditional. So out of the people that smoke regularly, okay, so the probability that they have hair loss given that they smoke, we'll say it like that. So out of the 240 people, 135 have experienced hair loss. So you can do it that way, or you can do it based on the formula and the table, or you can just think about what the question is asking you. Okay, so 135 out of 240 ends up giving you 9 out of 16. All right. For number 7, the probability of A is 0.28, B is 0.31, and the events are mutually exclusive. For two things to be mutually exclusive, that means that they can't happen together. So the probability of A and B is equal to 0. That's what that means. So I'm looking for the probability of the or. So the probability of A or B is equal to A plus B minus the and, which just happens to be 0. So this gives me an answer of 0.59. Okay, the probability of event A or B happening is 0.59. All right, for number 8, the probability that Rebecca will pitch in her softball game is 1/6. So the probability that she pitches is 1/6. The probability that it's going to rain during the softball game is 3/7. So the probability that it rains is 3/7. The probability that Rebecca will pitch and it will be raining during the game is 1/14. So pitch and it will be raining is 1/14. Determine if the events are independent or dependent. So if two events are independent, in order for two events to be independent, and based on the information that I have, the probability of P and R would have to be equal to the probability of P times the probability of R. So this is 1/14. I need to see, is 1/14 equal to 1/6 times 3/7? So this gives me 1/14 is equal to, when I multiply these two over here, I get 1/14. So they are the same, which means that these events, my answer, is independent. Independent. All right, so you have to show some type of work for that. I understand that a lot of you are thinking, you know that independent means that one event has no effect over the other. I know that some of you are thinking that the rain has no effect on whether or not she's going to pitch. Okay, I mean, it could have an effect. Maybe she pitches better in the rain, so the coach wants to put her in. You have to do this by showing some type of work using the probability. Okay? Number 9, if the probability that a school will be open for the day is 5/7, so the probability of open is 5/7, and the probability that it will snow is 3/19. And the probability that it will be open given that it is snowing. Open given that it is snowing is 17/20. Determine if these are mutually exclusive, independent, or neither. So let's see first. The one that you can tell right away, not necessarily right away, but the one that's a little bit more easy for you to see, is that these two events are not going to be independent. If two things are independent, if they are independent, that means that the probability of, I'll stick with the letters that we have, the probability of O given S is the same thing as the probability of O. Because it's snowing, right? Independent means that one event has no effect over the other. It's snowing has no effect on whether the school is going to be open. So the probability of it snowing is it being open given that it's snowing is 17/20. And the probability of it being open is 5/7. These two things are not equal. So these are not independent. In order for two things to be independent, one event has no effect on the other. It's an individual event, right? Think if you were to describe yourself as independent, what would that mean? That would mean you don't rely on anybody else. Okay? And then mutually exclusive. Again, we said mutually exclusive means that the two events can't happen at the same time. So I would have to find what is the probability of open and it's snowing. So one way I can do that, I know I have a given and I have I have a conditional and I have the given. I know that the probability, so this one's a little bit tricky to see. The probability of O given S is equal to the probability of O and S divided by the probability of the given, right? The probability of a conditional is equal to and divided by given, or both over given, I think I said in class. So this here, I know that this is 17/20 is equal to, I'm looking for this, I'm going to call this X. just to save some space, divided by the probability of it snowing is what? Is 3 out of 19. Okay, so the way that I'm going to solve for x is by cross multiplying. So this is like over 1. Okay, because remember you have all of these fractions are in here, so there's a lot going on. So x equals, if I do 17 divided by 20 times 3 divided by 19, that gives me 51 divided by 380. So this is this. The probability of O and S is 51 divided by 380. That's not equal to 0. So that means that this is not mutually exclusive. So for number, what number is this? For number 9, you get neither. This is neither independent nor mutually exclusive. Okay? All right, and that's it for probability. So the rest we're going to talk about recursive formulas and arithmetic and geometric, and then we're going to just do some quick review questions. So for number 10, state the first 4 terms of the sequence. You are given the recursive formula. A sub 1 is equal to 3. To find any term in the sequence, you're going to do 2 times, remember this just means the previous term, 2 times the previous term minus 5. So A sub 2 is equal to 2 times the previous term is 3 minus 5. That gives me 1. So the first term is 3, the second term is 1. The third term, 2 times the previous term minus 5 gives me negative 3. So the third term is negative 3. And then the fourth term, 2 times the previous term minus 5 gives me negative 11. So the first 4 terms in this sequence, it starts off at 3, and then 1, negative 3, negative 11. That's all it wanted for that one. Okay, again, please don't overthink the recursive formulas. For number 11, in a theater there are 16 seats in the first row, and every row after that has 2 additional seats. Okay, this is arithmetic. You are adding each time. The first term, you have to state the first term. The first term is 16. This is arithmetic, so you have a common difference. You are adding 2 each time, so the common difference is 2. This one's the recursive formula. Recursive formula, you need to have a sub n minus 1. Meaning the previous term. What are you doing to the previous term? Here, a sub n is equal to, I am taking the previous term and I am adding 2 to it. That's all. In number 12, we have 3, negative 12, 48, negative 192. Here, the pattern, this is being multiplied by negative 4. So this is geometric. Geometric, and r is equal to negative 4. Again, you have to say where you are starting. A sub 1 is equal to 3. And now your recursive formula, a sub n is equal to, you are taking the previous term, and you are multiplying that by negative 4. So you might want to, looks a little bit cleaner with the negative 4 out front. If this were multiple choice, it would probably be written this way, okay? And then it wants to know the 7th term. So I have that the 4th term is negative 192. So the 5th term, I would do using this formula. The 5th term, I would do negative 4 times negative 192. Gives me 768. The 6th term, I multiply that times negative 4, gives me negative 3072. And then the last one, so this is my answer here. A sub 7 is equal to 12,288. So notice the recursive formula, again, can be very difficult to work with if I ask you for a high number. If I ask you for the 20th term, you're going to be sitting here for a while. So that's when you would use the explicit. Okay? Number 13. Nathaniel wants to increase his swimming endurance. On the first day, he plans to swim 6 laps, and then every day after that, increase it by 10%. So this is geometric. This is geometric. And the R value here, the common ratio, okay, the common ratio, if you want to increase it by 10%, you want to take 100% of what you have and add 10% to that. So you are multiplying each term by 1.10. 100% of what you have, and you add 10%. So you have to say that the first day, the first term is 6, and then every term after that, you are going to do 1.10 times the previous term. Okay? All right, so that's all the new stuff. Old stuff, number 14, the equation of a curve equidistant to a point and a line. That is a parabola. Okay, you draw a parabola out. 4, 8 is somewhere all the way up here. Y equals -2 is down here. I suggest that you draw all these slashes. So I have 1, 2, 3, 4, 5, 6, 7, perfect, 8. And then I have 1 and 2. So there are 10 spaces in the middle here. So if I count 5, if I go down 5 from the focus, that gives me the vertex. The vertex is at 4, 3. Right, I had it over 4 here. The parabola is concave up. The p-value from here to here, I am going up, so positive 5. So p is equal to 5. The parabola formula, right, for a vertical parabola, it is x minus h squared equals 4 times p times y minus k. So this is x minus 4 squared equals 20 times y minus 3. All right, and then number 15, this is probably the most involved question that's on your review sheet. Using long division, rewrite this as the product of linear factors if x plus 6 is already a known factor. It just means it wants you to factor this. The problem with factoring that is that the way that it's written right now, it is not factorable for you. So it wants your final answer to be this times this times this, and then you have one more. I have 4 linear factors because this is 2x to the 4th. Okay, x plus 6 is already a known factor, so I know that one of them is going to be x plus 6. So that's what you're doing essentially. So how do you do it? So I'm going to get rid of this so we have some space. All right, so it tells you you have to use long division for this. On your test, it might not tell you that you need long division. Okay, it might just tell you that whatever is a factor and define the other one. So x plus 6, I'm going to divide that into 2x to the 4th plus 9x to the 3rd and then plus 288. Now I know whatever I do here, I need to get a remainder of 0 because I already know that x plus 6 is a factor. So it has to work out for us that we get a remainder of 0. So I do 2x to the 4th divided by x gives me 2x to the 3rd. That comes up here. I multiply it out. 2x to the 4th plus 12x to the 3rd. Right? I'm multiplying this times the divisor. Okay? I put this in parentheses and I subtract. 2 minus 2 cancels. 9 minus 12, negative 3, x to the 3rd. I bring down my next term, negative 50x squared. That is one round. If you can do that once, you can do that for the longest polynomial long division problem ever because it's all the same thing. Okay, so negative x to the 3rd divided by x, negative 3x squared. Multiply it out. Negative 3x to the 3rd minus 18x squared. Put it in parentheses, and I subtract. This cancels out. Negative 3 minus negative 3 cancels. Negative 50 minus negative 18 gives me negative 32x squared. Bring down the minus 144x. Negative 32x squared divided by x gives me negative 32x. Multiply it out. 6 times negative 32 gives me negative 192x. Parentheses, subtract. Negative 32 minus negative 32 cancels. Negative 144 minus negative 192 gives me 48x. I bring down the plus 288. 48x divided by x gives me plus 48. Multiply it out. 48x. And then 48 times 6 gives me 288. Parentheses and subtract. I get 0. So I know I did it right. So I can rewrite this whole mess. I can rewrite that as x plus 6 times 2x to the third minus 3x squared minus 32x plus 48. Now, if this asks me to rewrite as the product of factors, technically I would be correct. However, this says linear. So everything has to be broken down. That way each factor is only x to the first power. So x plus 6 is fine. That's done. Here I split this down the middle. I do factor by grouping. I take out x squared. I'm left with 2x minus 3. On the right, GCF is negative 16. I am left with 2x minus 3. So this is 2x minus 3 times x squared minus 16. And don't forget, you still have that x plus 6 out front. Now, we're still not, this is a better answer, but it's still not perfect because this says linear factors. The problem with linear factors is that you have this quadratic factor. X squared minus 16 I can factor using dots. So this is x plus 6, 2x minus 3, and then x squared minus 16, square root of x squared is x, square root of 16 is 4, plus and minus. Okay? So if I multiply all of this together, I end up getting this whole long polynomial. Okay? But the reason why you can't factor this by hand right away is because all of the like terms and everything are combined. It's not set up for you to factor right now as it is. All right, and then the last question wants a sinusoidal regression. A sinusoidal regression that can be used to fit the data above. Rounded to the nearest hundredth, x equals 1 is representing January. So in your calculator, you need to make sure that your work is everything that you see on your calculator screen. So this you're going to plug into L1, right, where January is really x equals 1, February is 2, March is 3, so on and so forth. L2, you can plug in 4.4, 3.2, you can plug that in like normal. Okay, this wants a sinusoidal regression. So after you plug those into L1 and L2, you are going to press Stat, slide over to Calc. You're going to calculate, you want to calculate a sinusoidal regression. So you slide down until you see sine regression. And then you just keep pressing enter until it gives you everything. You have to write this on your paper. I understand this says rounded to the nearest hundredth. I don't care about that yet. Right now, I need to write everything I see on my calculator screen. All right, so I wrote down everything on my calculator screen. That is my work. The answer, though, is then rounded. So the answer is all of that plugged in. So y equals, we're rounding to the nearest hundredth now, because this is technically like my final answer. Y equals A is 2.51 times the sine of B is 0.41, x plus 1.78, close the parenthesis, plus 2.62. That has a decimal there. Okay, and that is my final answer. Remember, extra help is going to be Wednesday after school for your test on Thursday. Everything's a little different this week. It's all pushed up. Okay, have a good night.